All right, everybody. So I'm going to continue with the functions today. Today's topic is about composition of functions. So we're going to learn what that is, how to find it, and also learn how to evaluate composition of functions. So the concept of composition of functions is not complex. Basically, it just, when you say composition of something, so when you take two things and you put them together. You plug something into something, or you mix things together. Your mic, everybody.
Unmute or mute?
Mute it.
Oh, mute it? Okay.
Especially you, Rosa, I think you have some background noise. All right, so let's see, define a composition of functions. So the word composite or composition is when you put two things together, you mix two things together to get a result that is called a composition. So before we deal with actual functions, let's visualize this. Let's take, for example, consider this container as a function. Okay, let's call this F. Then let's say we have another container, maybe.
Hi, Professor.
Please mute your mic, everybody, if you have noise. Then let's say another shape. Let's call this G. So let these two be two functions. Okay, we have F, we have G. We want to find the composition of the two. We're going to take these two, and we're going to mix them up and end up with a new function called the composition of the two. So we call that F of G. So when we mix these two, we get a composite. This is the notation, and it's read F of G. So we read it as F of G, or you can also say F composite F composite G. F of G or F composite G. This is not a dot, it's not a multiplication, it's a little circle, which means it's a composition of functions, not a multiplication. If you see this, this is a product of F times G. You take the two functions, just like we did with polynomials, and you times them if we have a dot, but this is not a dot. Do not confuse the two. I see a lot of people confuse these. This means composition. So F of G, or F composite G. What it means is the composition of this function and this function. So basically, when you say that, so you want to find F of G. So it's basically just plug in the second function into the first one. That's all it is. We take whatever function this is, we plug that into the function. The result will look something like this. This is just a visualization, so it's not in the actual functions. So you see here the composition of the two. This is what we call F of G, or F composite G. Basically mixed together, they make a new function. This is a function F, this is a function G. When you mix them together, when you plug one into the other, you get a new function with its domain, graph, and everything. So now, let's see how to do this with actual functions. So this is just some models, but let's actually use two functions. Say take f of x, maybe 3x plus 1. We need another one. So to make a composition of functions, you need at least two functions or more, at least two. So g, let that be, for example, just maybe 2x. So let's find, f of g of x. We can add that here. So we see f of g need a variable. Just means which letter they have. Do they have y here or x? Whatever letter it might be, we put it here. So this means f of g of x, f of g of x, or we can also call it, as we said earlier, f composite g. This is just a variable. This is not a multiplication. It does not mean a multiplication here. It just means that these two functions, the letter they have or the variable is x. And f of g of x. So in this order, you plug the second one into the first one. Just like we did here, take the second one, you plug it into the first one. The result will be called the composition of the two. It's very easy to do. All you have to do is write the first one. In this case, this one here. So we're going to write it down. So 3. I don't want to write the x yet. I don't want to write this x. I'm just going to leave a blank space with parentheses. So plus 1. Okay, so that's the first function f. I write it down. But write it down without the x. If you have more x's here, just leave them blank, put some parentheses. Now, what do you think goes inside the parentheses here? If you want to find f of g, what do you think goes inside these parentheses? So again, we're trying to plug g.
X? No.
We're trying to plug g into f. So we write the first function f, we did, without the x. So
It's gonna be -2.
not -2, it's just this. So g into f. This is f. And inside of f means inside the x, we're going to plug the g. What is g?
2.
G is given. It's 2x.
X.
That goes here. That's it. We just found the composition. So this is f composite g. Again, it's not a complex concept. Write your first function, whatever it might be. Leave the x in that function blank. For example, you don't write the x. And then inside of that x, inside of that empty space, we put the whole function g. Whatever it is, could be a longer expression. The whole expression goes inside, or it goes where the x was, where the x of the first function was. Once you do that, you can try to simplify it a little bit. For example, we can times these two. 3 times 2x, that's 6x, plus 1. And that's it. So we can't simplify anymore. So this is what we call f composite g, or f of g. We just plug in one function into the other. Let's do another example. Let's say f of x. For example, radical x. G of x is maybe 5x minus 1. So let's find both. We're going to find f of g of x. So f of g of x. Which function goes into which in this example? What function do we plug in which function?
5x minus 1.
Right, so g will be plugged into f. Always start with the second one, plug it into the first one. So to do so, write this one down, f is here, is given. This is f. We're gonna write it without the x. So the x is basically gonna leave it blank. So the x, just put some empty parentheses. So now what goes inside the parentheses? We're doing g into f. So what goes here inside the parentheses?
5x minus 1.
Exactly. So we're going to put g. So g goes into f. Write f first. We did. Inside of that, we're going to put g. What is g? It's given. So g is equal to this whole thing. So we're just going to plug it here. And that's basically it. See this mix here, this composition? That's what we meant earlier when we plug 1 into 1. We get this mix here, a composition or a composite of two functions, or sometimes more. If you have more, you can do the same thing. And the order matters, the order of the function matters. F of g is not the same as g of f. G of f of x. Again, this is not a multiplication. It just means of x. What variable do they have? They both have x and x. If the variable was y and y, you would put g of f of y. But in this case, it's x. Could be any variable. Okay, to find this, which function do we write first?
G and F.
Which function do we write first out of the two?
5x minus 1.
That's right. We'll write g first. We're going to write g, which happens to be, again, this, 5x minus 1. So we're going to write g. Remember, do write it without the x. Leave the x blank. So 5x, we're not going to write the x, just that, minus 1. Okay, so we'll plug in f into g, always the second one into the first one. We write the first one first, we did, without the x. What goes into the parentheses now? What goes inside parentheses?
The
function f, right?
function, yeah.
What is the function f? It's given. What do we plug inside the parentheses?
2x.
Nope.
No, it's that.
What do we plug in? What do we plug in inside?
The first one. The F.
So,
Yeah, that.
radical 5x. F went into g. That's it. We took this and we plugged it here. So we took f, which is radical x, we plugged it into 5x. This basically is the composition g of f. It's not the same as f of g. So the order matters. Always plug the second one into the first one to get your composition. So that's the whole idea of composition functions. When you need to find a composition function, just plug one function into the other. Okay, does that make sense to everybody?
Yes.
Yes.
Please let me know.
Yes.
Okay, we're gonna do a couple more examples. All right, let's do one more example. Let's say h of x, 3x to the second plus 5x minus 1. Another function may be k. And we're going to call this maybe radical x. Then we can find h of k, again, of x. And after that, we can also find the other way. So the question will tell you what to find. This is h of k, or it might be k of x, k of h. Don't forget that variable here, x. All right, so which one do we write first again to find this composition?
So it's gonna be
Which function do we write first?
3x over 2.
That's right, we're gonna write the h, which is this. So it's gonna be 3.
Mm-hmm.
And again, we're gonna write it without the x.
Yeah, over 2 plus 5. Without the x minus 1.
That's right, so this one would be equal to.
So why is it a plus instead of minus?
It should be a plus, it should be a minus, that's right.
Okay.
My mistake. So this one will be Someone has background noise. I believe it's such as hear birds or something next to you. So we write the first function again that appears in the notation. So this is a notation. It's just the way we write the composition. Start with your first function, whatever it might be. Write it down first. H, for example, here. So we write the expression of H. We did. Just leave the X blank. Again, don't write the X. Inside of that X, here, this function will be written inside of these parentheses. So we're going to take that K into H. So K goes into H. We wrote the H first. Inside of the parentheses, we're going to write the whole function K, whatever it might be. In this case, happens to be just radical X. We're going to write radical X here, also radical X here. Then we'll try to simplify your radicals or your expressions just like we did here. For this time, we're going to cancel this and this. Radical and the power cancel each other out. I'm going to talk about radicals in detail in the future. But for now, you can just remember that radical or the square root cancels against the second power. So we end up with 3x plus, now multiply these, basically they stay the same. That's it. There's nothing else we can do to this expression. That's basically the composition of the two functions. The next one this time is the other way around. It's K of H, not H of K. Always start with the first one, write it down. So we're gonna write K first. K is given, it's this. So we're gonna write the K, but without the X. Just leave a blank for that X or parentheses. So we're gonna write radical, and this is the X. So we're gonna write K first, without the X, we did. And what do we put inside the X? What goes inside this space? The whole function H, which happens to be this, because we're looking for K of H, which means H into K. So the whole H will go into K. H is given 3x to the second minus 5x or plus 5x minus 1. And that's it. That's your composition of the two functions. Okay, again, we just blending or mixing two functions together to get a new composition, new product. Just like, I don't know, you mix eggs and flour together. When you mix them, you get a new mix, the dough for cookies or whatever. That will be the new mix. If this was, like, say, eggs, and this was, I don't know, flour. So we mix one, or we put one into the other. For example, we put this into this and mix them up. So the result is E of F, eggs and composition F. So eggs and F together, they make a new mix or a dough for cookies, as I said. So that's the composition. Just think of it as a mix of two functions, or could be more. If you have more functions, you could do the same thing. You just plug one into the other. Always start with the second one into the first one. And don't let this notation scare you. F of G of X, it just means we take these two, we mix them, and this is the variable they both have. They both have X in them. So F of G of X, F of G of X. If you don't like that notation, just call it a new function. So when you mix two, the result is a new function. Call it whatever you want to call it, for example, K. Here, we can call it, for example, just function K. K of X. If we want to give it any name, it doesn't matter. So let's call it K of X equals this. Where did K come from? Where did it come from? It came from the composition of the two. You can also rename this if you want. So H of K of X, you can give it a more meaningful name. If this, again, this doesn't have to look confusing or complex. It just means putting two functions together. Okay, is everyone on board at this point? Everybody?
Yes.
Yes.
Make sense?
Yes, Professor.
Yeah.
Okay. Okay, so again, notations or symbols shouldn't scare you. We just notations we use to name functions or to give them symbols. So that's how you find the composition of two functions. Now let's see how to evaluate them. Second part, let's call this evaluating. Composition of functions. This part is easier than the first. So the notation sometimes could be f of g of x, right? So let's say you have two functions f of x. Let's say x to the second, for example, plus 1. We need another function, g of x, maybe 3x. So the question says find f of g of x, f of g of x. We know what to do, just like this. So you plug this into this. But sometimes you may see a specific value here, not x, but this is generic. That means they both have x, and x is a variable. It could be anything as long as that x belongs to the domain of the functions. Could be any number, for example, 1, 2, 3, -4, as we saw last time with graphing of functions. You can plug different numbers into x, and we get some y back. So same thing here. Sometimes you may see notation like this. Say a specific number may be, let's say, 4. So this is f of g of 4, not of x, but of 4. So say f of so this time we need to evaluate. So when you have a value here, you know that you need to find a specific number. The result here would be a number, okay? Not a function like here with x and numbers. It's gonna be a specific value. That's what we call it evaluate. So we have to plug. Basically what we do is this 4 will be plugged into this. The 4 will be plugged into this mix. But the good thing is you don't have to find the mix first. You don't have to find this first and then plug 4 into it, unless you have that mix. If you already have it, if you already have the compositions of the two, maybe from the previous question, for example here, you plug g into f, you end up with a new function. This is a new function, you can plug 4 into it. If you don't have it, you don't have to find it. We have an easier way to do it. You can do it in 2 steps. First, we find this, g of 4. You evaluate the function the closest to the number or the value given. So we say, so we're gonna find g of 4. Just evaluate this, one function, one number. How do you find a g of 4? Given g, we have g here. What is g of 4? What do you do to find it? What do you plug into what? Just the g of 4. Remember what we did last time with the graphing of functions. G of 4 means plug 4 into g. G is given here. Okay, if you plug 4 here, what do you get? If you plug 4 into g, if you plug 4 here, what's the result? 3 times. Everybody?
12.
4.
Be 12. 3 times 4.
12, yeah.
Okay, that's how we evaluated functions the other day. So one number into the function. That's the first step of finding this whole thing. So evaluate this first, which is easy. Then you do another evaluation, this time with this one. The number we just found goes into the first function. So we did this, we found this to be 12. Now that 12 will go into f. So I'm gonna say f of 12. The 12 came from here. The 12 is the result of the first evaluation with the function that's closer to the value given, in this case 4. How do you find f of 4, f of 12 again? You plug what into what? Everyone, how do you find f of 12?
You put the whole expression in.
4 multiplied by 3.
We're going to plug 12 into f. F of 12 means 12 into f. What is f? F is given. I'm going to take 12 and plug it here. Instead of x, it will be 12 to the second plus 1. We plug 12 here, 12 to the second plus 1, which is 1, 40, 40 what?
5.
Right, because 12 to the second is 12 times 12, that's 145, 144, added to 1 is 145. So that answers the question. So the second value you get is what answers the question. So our answer to this is this. So f of g of 4 equals 145. We did it in 2 steps. You can do it in 1 step if you want. If you want to find the composition first, that's fine. If you want to plug g into f, like we did here, get that composition first. Once you find the composition, you can plug 4 into it. Or you don't have to. If you have a specific value here, just evaluate this first, get that value, and whatever you get from here goes into the first function, f of 12, evaluate it, you get 145. Okay, so the question may tell you what to find, so you can use either way you want. This is probably easier. So you don't have to find the actual composition here, we just evaluate twice. But again, if you want to find the composition or if you already have it from a previous question, let's say for some reason, you already had this from a previous question, you can do that as well. Let's try that second method now, which is probably maybe the least easy one. Let's find f of g. So what would f of g be? I'm gonna write f first, and then plug g into it. Write f, which is this. So it'll be x to the second plus 1. Okay, write f first, we did. Then we want to plug g into f. So what goes inside the parentheses here? So we wrote this function without the x. What goes here now inside of the parentheses? Everyone, what goes here inside the parentheses?
3x.
3x, that's right. So we're plugging g into f. We wrote f first, we did, without the x. Always when you write the first function, write it without the x. Into that x goes the value, the whole function g, whatever it might be. It could be more than just one term, you plug the whole thing. So g goes into f. So this is g, goes into f. So this would go into here. If you simplify this, you'll get 3x times 3x, that's 9x2 plus 1. Now let's do the same question here, f of g of 4, but knowing this, using the composition. So basically, the 4 goes into the composition. What is the composition? Is here. So the composition, if you already have it, feel free to use it. If you don't have it, you don't have to find it. Just evaluate this first, then what you get from here goes here. So let's try to find the same answer here using the composition of functions. So f of g of 4. So let's find it over here. So 4 goes into the composition. Now that we know the composition, okay, we have it. We're just going to plug the 4 into this, into the composition, which happens to be here. So the 4 goes here inside of the x. So 4 goes into the composition. This is the composition. So it would be 9 times what? The 4 into the mix. The mix is this one. What goes inside the parentheses? What do we put inside the parentheses?
3.
Nope. 4 into the composition. Here is the composition. So what goes here?
3, right? No.
Not 3. It's
4.
4. There's 4 into the composition. F of G is this. We just found it. So we're going to plug that 4 into that. Okay. And plus 1. 4 into F of G. Why? Because we happen to have it. So we take advantage of it. If you don't have this, if you don't have the composition, you can always use this way, which is easier. Evaluate this, then this. Okay, let's simplify this. What do we evaluate first in this expression, in this arithmetic expression? Think about the order of operations. What evaluates first?
The exponent.
The exponent, very good. 4 to the second, that's 16. L9 plus 1. What do you evaluate next? What do we evaluate after that?
9 times 16 plus 1.
That's right. What is 9? What is 9 times 16?
144.
144 plus 1 would be?
140.
145.
Exactly. 144. Here's 145. As you can see, it's the same answer we got earlier by not using the composition. We just used the evaluation. We did it twice. So basically, this kind of saves time, if you will. So if you have the composition function, imagine if you have 10 functions here, f of g of h of 10 of of k of h, whatever, and you had a value. So you don't have to do the same thing multiple times. It's better to just save time and plug it into the mix. Imagine you're trying to carry, let's say, 5 items, right? Say you carry something, 5 items, item 1, 2, and 3, and 4, and 5. You want to carry this from point A to B. Would you rather carry each item, 1 item at a time, and do 5 trips? Or would you rather put all these together into a composition and carry the whole thing at once from A to B? Which method is better, 1 or 2? If you had to move 5 items, let's say from point A to 1B, do you want to do that individually like here? Evaluate each one by itself, means carry each item by itself from A to B and repeat the process 5 times? Or do you want to put all these together into a composition, maybe a box here, and carry the whole thing at once? Carry the whole thing at once from A to B. Which one is better, 1 or 2?
1.
You said 1?
Yeah.
Why did you say 1?
The second example you did, right?
Second, you would rather put all these together. This is basically like, think of it as a composition. You put all those items in one box and travel once from A to B instead of having to travel 5 times or evaluate 2 or 3 or 4 or 5 times depending on how many functions you have. So that's the purpose of composition functions. Basically, it's a new formula that's supposed to save time. So if you have it, it's a new composition. So instead of using f and g every time and plug in and simplifying, why not use the composition of the two, which is itself, it's just a function. Whatever we can do with f and g, we can do with the composition. I'm sorry, say it again?
Will the numbers always be provided like Norman?
Yes, yes. The questions will give you the functions, will give you the numbers. So if you have the number, remember what to do. If you have x, not a number, also remember what to do. Basically this, find the composition. So you'll have both. Okay, so that's a little analogy or a little visualization, if you will, if that makes sense. So basically, if we prefer to have a composition, instead of having to use each function individually over time, like here, we would rather just plug everything into one function and use that function. Okay, everybody. Any confusions, questions?
No, Professor.
No problems. Everybody in the room, please make sure you understand this. Let me know if you have any questions. It's not complex. Again, don't let these notations throw you off. Just some simple concepts. Just plug in something into something. Let me give you some examples here. Let's say, okay, let's make up a couple of functions, maybe 2x minus 3, g of x, probably x to the second plus 1. So let's say find f of g negative 1 f
I'm sorry, I'll be disconnected.
for g of 2, and then g of f maybe 1. So notice we have values here. So you don't have to find the composition unless you have x. If you have x here, then you can do this to find the composition. But luckily here we only have values, so we can do it the easy way here. Or if you prefer to find the composition first like we did, and then use the composition to plug the values into it, that's also fine. Okay, let's evaluate this first one, f of g of negative 1. How do you do that? What do you find first? If you want to evaluate this, if you want to do it this way, like we did here. So what do you find first?
Don't we just find the x value and then just proceed further with the -1?
So the x value is here. We have it. It's negative 1. So
Okay.
we want f of g of negative 1. So there's two ways you can do it, as we saw here. If you want to find the function first, the composition, find it first, that's fine. Or you can do it this way. If you want to do it this way, which is probably the easier way, how do you do this one similarly to this one? What do we evaluate first?
The g value?
That's right. Do g of negative 1. Just like here, always evaluate the one that's closer to the member.
So it's going to be minus x square root 2 minus 1.
That's right. So we're going to plug negative 1 into g. Make sure you use the right function, not f but g. So it's going to be negative 1 to the second. We're going to plug negative 1 here. And plus 1.
So it's going to be 1 plus 1.
That's right. That's
So
right.
g is going to be 2.
Which is 2. Very good. Are we done with evaluating this?
Yep, we are.
No, the whole thing. So we just did this.
Oh, I thought you were talking about only g. With the g, we are done, yes. And now it's an f turn, so it's going to be minus 2x plus 3.
Mm-hmm. Where do we plug the 2 now? So evaluate this first. We got 2. What do we do with the 2 now?
We're about to multiply it to.
That's right.
It's going to be minus 4x plus 6.
That's right. So plug the 2 into the first function. So we evaluated this. G of negative 1 is 2. We take the 2 and we plug it into the first one. So we're going to do f of 2. F of 2. So we're going to plug 2 into the function f. This time we're using f, not g. We use g for the first evaluation. Now we're going to use f for the second. So f of 2 will be 2 here. So we're going to plug 2 here. It will be 2 times 2 minus 3. Which is basically 1. So the second evaluation is basically what answers the question. Okay, so the second value is the answer. So you have to evaluate twice. So that's what answers the question. So this is equal 1. Okay, let's do the second one, same way. F of g of 2. What do you evaluate first? F of g of 2. Which evaluation do we do first? Everybody in the room, please tell me what to do here. I want to make sure everyone understands this.
Okay.
So we want to do f of g of 2. Which evaluation?
G2
That's right. Let's do g2 first.
equal 2 to the power 2.
That's right. G of 2, gonna plug
Yes,
here and also here, so 2 to the second.
to the second power
That's 1.
plus 1. It's gonna be 5.
Okay. Now, what do we do with the 5? We plug
F.
it.
Oh.
So we're gonna plug it into F. So we did this. This is 5. It goes into F. So F of 5. This time we're using the function F. We're gonna plug 5 into F. F is given to this. We're gonna plug 5 here and here. So F of 5 would be 2 times 5 minus 3, which is 7. And this is our answer. So this is, I'm gonna do it in 2 steps. If you prefer to do this way, that's fine too. If you wanna find the G, if you wanna find the composition first, get the composition and then use it, that's fine, you'll get the same answer. But either way is fine. I believe this is probably easier. I've seen people prefer this way over the other, but you can use either one, it's not a problem. Finally, now we have G of F of -1. What do you find first again? Which evaluation you do first? G of F of -1. What evaluation do we do first?
F.
X to the power plus 1.
That's right, we do F. Please mute your mic if you have background noise. So this time it's F that's closer to the number. So you do this. Always evaluate function closer to the value. So it would be F.
F minus 1 equal -1 to the power 2.
Nope, we're gonna
To
plug
this-
it into F.
Oh no, it's 2x minus 3, right?
That's right. So F
So it's 2 parentheses -1
Yeah.
minus 3.
exactly, is 2 -1 minus 3, because we plug in -1 into F, not G.
Okay.
So it's -2 minus 3.
That's right. I'll be
-5.
okay. What do we do?
And then G.
That's right. Now we're gonna take this one, plug it into G. So this one went here. This one also went here. So now we're gonna take the -5. We'll go into the first one. So we did this F of -1. That's -5. That goes into G. It'll be G of -5. Be careful which function to use this. G. Now we're using G, so we're gonna use this one here. So -5 into G would be -5 to the second.
To this second power
That's right.
plus 1.
Which will be
It's gonna be -20.
we
Oh
20
wait,
positive 26.
-5 to the second power is gonna be
Positive.
25. Okay, plus 25. Yeah.
Right? So we plug this number into G. So that's basically how you do your composition of functions. Again, make sure you use the right functions. Make sure you know what you're looking for. If it says find, if you have X here, that means you have to plug one function into the other. If you have a specific value, you don't need to plug a function to the other, you can evaluate it twice like we did. And you can use either way. You can use this way that takes 2 steps, or if you prefer to do this way, if you want to find the composition first, then that's not a problem. Okay, that is basically how you find the composition functions and how you evaluate them. Evaluation is when you have specific value here, not x, but specific value, and you plug it into here to find a specific value. As you can see, every time the answer is a specific value. That's why we say evaluate. But if you don't have a specific value, if it's just x, that means you in general, you just find the composition, which always, most of the time will have x in it, will be a function with x. Could be a constant, but that's basically how you find the generic function itself. And here, this is how we evaluate it. And again, don't confuse this with f times g, for example, of maybe, let's say, 3. Okay, if you see this, it's not composition, it's just a multiplication. Basically, what this means is f times g, and we plug 3 into that. What you do is you write f, okay, you write, you basically find an f of 3, and you times that by g of 3. You find this one first, and you find this one, you need times the 2. That's the difference. Unlike here, when you have to find the first one first, whatever you get goes into the first one. So if you continue with this one, what is f of 3? If you plug 3 here, so f of 3, plug 3 would be 2 times 3 minus 3. And that you're going to multiply. So this is first one f of 3. Now we're going to g of 3. I'm going to plug 3 into g. Here is g. G of 3 will be 3 to the second plus 1. Then you do the parentheses first. That's 6 minus 3, that's 3. Times 3 to the second, 9, plus 1, 10. Finally, you multiply the 2, you get 30. Okay, so do not confuse this little thing, that's composition, with this. If you see this, it's a multiplication, it's simple. Find f of 3 and times it by f of 3, just like here. If it's a composition, then you have to find the first one. Once you get it, you plug it into the second one. So be careful. I see people often confuse the composition with the multiplication, so they're not the same. I hope this makes sense to everybody, or at least to most of you. It's not that difficult. It's not that complex as you may seem, just some notations. Rewatch this video later if you need to. If it doesn't make complete sense now, if you still have any confusions, please rewatch it. And I'm sure it will make even more sense. Any questions, everybody?
Nope.
All right, one down.
No.
No.
Perfect time to ask. You know, if you don't ask now, you may never ask, you may never learn it. So always ask,